Good morning. Welcome back. Last class, we started with queues, which is again a linear data structure wherein the insertion happens from the rear and the deletion happens from the front. So we did the insertion operation, like how exactly the queue insertion, queue insert or NQ operation works. It's nothing but like first you need to check whenever you are entering or inserting an element into a queue, first you need to check for the overflow condition, which is nothing but to check whether there is any space available in the queue or not. That is the first thing you have to do, because if there is no space, then there is no point in taking the element from the user and trying to insert it, right? So if rear is equal to n minus 1, why am I checking for n minus 1? Because 0 to n minus 1 your elements would be placed. Since this is a array based implementation, so I will have 0 to n minus 1 the location of elements, that is n elements. So 0 to n minus 1 would be n elements. If the rear is pointing already to the n minus 1th element, it means that there will be no space in your queue. It gives rise to the queue overflow exception. So it will print you that and it will go. Suppose if that is not true, that is, it means that there is some place in your queue. So it gives rise to two different scenarios. One is the entire queue may be empty and whatever you are going to insert may be the first element, or the queue already has some elements but it is not full, you can add in elements to it. So these are the two cases if the queue full is not true. So we need to check for both, because if there are no elements in the queue at present and whatever you are inserting is the first element, then you need to reset or reposition both the pointers, right? Because front also should point to the first element, because that would be the element to go out of the queue first, and rear also because that is the element which is being inserted. So then I will say reset the pointers. If front is minus 1, front would be minus 1 in the case of an empty queue. Otherwise it will have some value. What value will it have? It will be pointing to the location which is to be deleted, right? So if front is minus 1, then I will reset. It means that there are no elements in my queue and I need to reset or reposition the pointers front and rear to 0th location, since the element you are inserting into the queue would be the first element and location of that would be 0, because the location would vary from 0 to n minus 1. So if front is equal to minus 1, front is equal to 0, rear is equal to 0, I will do. But suppose this is not the first element and my queue is not full. There is still place in my queue. So what should I do? I have to increment my rear pointer. Why? Because the insertion happens from the end, that is the rear end or tail of the queue, and rear is a pointer which keeps track of the elements for insertion. So rear would be pointing to a location of the last inserted element. So you need to increment it by 1 so that it points to the next blank location, so that you will not be overwriting on the already existing one. And then q of rear, because rear is equal to not rear is equal to item will give you error, because q of rear, that is, you need to insert the element at that location, is equal to the element which you have taken from the user. And that is how this works. Hopefully you have understood the algorithm and the way it works. Now we will write a program to perform q insert or nq operation. Please make a note of this, and this also happens to be your lab program. So after writing it, explaining it, I will show you the execution of it, how it works, so that it will be very clear. You will have no doubts by the end of it. So write down the statement. Write write a program to perform NQ or Q insert operation. So I need to write a program to do the Q insert or NQ operation. So how do I start it? I would be starting with hash include statement. Hash include iostream.h include conio.h hash include. I will be using a character function, built-in function. So I will be using ctype dot head hash define size 5. So let me have a queue of 5 elements. That is maximum of 5 elements in a queue. After that, class in lowercase only, please don't write it in uppercase because class is a keyword. Q Q. So I'm naming my classes Q. Then if I don't specify anything, then also the access specifier, if I don't specify anything, also the access specifier would be private. But it is always a good programming practice to explicitly specify the access specifiers, because if you forget to specify public, then everything becomes private and it will not be accessible from outside. So always make it a practice, because in the exam, if you assume like, yeah, if you don't specify anything, it is private only, but then if you don't specify public, because if you miss out specifying that and write it, you want to and try to call it from main, you will lose marks there because it is not accessible outside. So make it a practice to write brackets wherever necessary, because even if it is one line, if or else or for, then also write the body, enclose it in proper brackets so that you will know while debugging how exactly what is inside and what is outside. So let me start with private colon. Everything is in lowercase. Anything in private will not be accessible outside, can be accessed by only the member functions declared in the class Q. So int, let me say Q of size, comma, front, comma, rare, comma, I, comma. Okay, let me not take item, like I will have front, rare, size, I, because I don't need n. I know already the size, and you're not asking the user to enter the number of elements here. So these are the data members of my class. So data members of the class, and next is I will have it as public, because I need to access these member functions outside the class. So I would be declaring it in public. So first let me start with, because why do I need this? To give initial values. That is, I need to give the initial values to the front and rear as -1. And if I give it here, that is in front is equal to -1, comma rear is equal to -1, it gives you error. Declaration and initialization cannot be done here in the class. It has to be either done in a member function or a constructor. Getting it? Next is void nq int. I'm going to pass an integer value to it. Next is void print, because I need to print. I want to print the q elements as and when I go on inserting elements into q. This completes my class. So what are these? These are the member functions of the class. Okay, these are the member functions of the class. Those are the data members of the class. I have in public q, whereas it's a constructor wherein I need to give initial values like front is equal to -1, rear is equal to -1, because to begin with my q would be empty and I cannot give it here only, that is declaration and initialization. It will give you error. It has to be either in a constructor or a class, or a function of the class you have to do. But then I want to do it in a constructor. So whenever you create an object, automatically the initial values would be assigned to front and rear. After that, I have a function called nq, which will be used for inserting a, to do the nq or the q insert operation. So what is that? That is the declaration of the function, which says that the function is not going to return any value and I am going to pass an integer argument to it. So this is the function declaration. The other one is print, wherein it is not going to return any value nor I am passing any arguments to it, and I have closed my class. My class Q has four data members and three member functions. In that, one is a constructor. Fine. Now let me write the definition of all this outside the class. So it is q is the name of the class, scope resolution operator, name of the function. So I will say front. I don't have to declare it again because I have already declared it. So if I try to declare it again, it will give me multiple declarations error. Rear is also -1 and I'm closing it. Front and rear, what are the values of front and rear now? The front and rear has values -1 and -1. Why is it so? Because in an empty queue, it will have -1. Suppose if I don't give initial values and I try to like, how will you check whether it is the first element or not? Because it will have any junk value, right? So this is how you will do it. -1 and -1 for an empty queue. I am not giving 0 because the subscript or the location of the first element is 0. If those two has 0, it means that at least the queue, if both of them have 0, it means that the queue has only one element in the first location. Getting it? The next one is the NQ operation. So how do I define it outside? Declaration inside and defining it outside. Written type of the function, name of the class to which it belongs to, scope resolution operator, name of the function, and the argument list if any. This is the general syntax of declaring a class declaring a function inside and defining it outside the class. So what is the written type of the function enq? It is void, which means that the function does not return any value. The name of the class to which it belongs to, scope resolution operator, and name of the function. And does it take any arguments? Yes, it does take one argument of the type integer. So let me name it as item. So what is this called? This is called the formal parameter. That is the parameter or the argument in the function header. Because defining it outside a function definition will have two parts. One is the function header and one is the function body. So int item, that is the variable in the or the argument in the function header is called the actual argument or actual parameter in the function header, right? Then let me start the body of the enq. Okay, so as according to the algorithm, what should I do first? First, I will not have any cout statements here because I'm going to pass item here. So I'm not going to take it from the user. That is why I don't have any variables also declared in the class, because I won't be taking any variables from the user. Here I would be taking it in main and I'm going to pass it as an argument to the function. So you won't have any cout and cin statements here. So first, what should I do now? First, I need to check for the overflow condition. That is what we wrote in the algorithm also, right? That is, you need to check for the overflow condition. That is, whether there is any place in the whether there is any place in the queue or not. So how do I check it? If so, rare is equal to double equal to, because you're comparing whether the LHS is equal to RHS or not. That is a relational operator which would evaluate to true or a false value. Size minus 1. Why is it size minus 1? Size suppose is 5, 0 to 4 would be the elements. So when it is pointing to the fourth element, it means that the queue is full, right? 0 to 4 is nothing but 5. That is why size minus 1. If rare is equal to size minus 1, it means that the queue is full, right? So what do I write there? Cout queue full, overflow. Right? And then I will say return. Go back. Okay? And I will close it. So what I'm saying, I'm checking for the overflow condition here. For the So always make it a point to write a comment also, because by seeing this you will understand why you're writing it. So it increases the readability of your source code. Now after checking this, if suppose this is not true, what will you be doing? See, if the condition, if for example I will say still there is place in my queue, like it is not overflow condition is not encountered, I do have some more place in my queue, then what will you do? So for that reason, if it is not true, what will you do? You will be going to the else part. So else, if the queue is not overflow condition of the Q is not true, then I will go to the else. Again in else, it can be the first element, or it need not be, it may not be the first element. If the element which you are inserting is the first element, then you need to reposition the front and the rear pointers to 0 and then insert. And if it is not the first element, then you are just increment the value of the rear pointer and insert, right? These are the two cases. Again, inside else, I will have a if and an else condition. So say if front is double equal to -1. So front would be -1 only if the Q is empty. Okay. If it is empty, that is there are no elements in the Q, the element which you are, the item which you are going to insert is the first item, then front would be -1. If this is true, I should make front is equal to 0, rear is equal to 0. So front is equal to 0 and rear is equal to 0. I am resetting the front and the rear pointers. Else, if this is not true, that is, this else is for the inside if. Please don't confuse. Outside if and else is different. The inside else is different. If that is not true, that is, if the entered element is not the first element and still there is place in my Q, what you have to do? You have to just increment the rear pointer. That's what we did. Now I closed my else also over here. That is the inner if, inner else is closed, and let me close the outer else also. So if is from here to here and else is from here to here, this is the outer else. Inside else again you have a if and a else. So now what will I do? I will say Q of rear is equal to item. Where do I get the item? Item would be sent from the user. From the calling function. So here I completed my NQ function also. See, NQ function starts here. In this I am checking for the overflow condition. How do I check it? Rear is equal to size minus 1. That is, I don't have any elements, and then that is why I don't have any place to insert elements. That is why I will say Q overflow or Q full. And I'll return back else. That is, if this condition is not true, again there are two cases: whether the element which you are trying to insert inside the Q is the first element, or it may not be the first element. If it is a first element, how will you know that? If front is equal to -1, front would be -1 only if for an empty Q. Then you will reset the front and the rear pointers to 0, right? Otherwise, just increment rear to the next location. Close this outer else, inner if and else, and then before closing the function, what you have to do? Q of rear is equal to item. That is, you are going to insert the element or the item into the position of Q of rear. This completes my NQ function. After that, I am left with which one? Print function. So how do I write it? Void Q, because it is the name of the class to which the print function belongs to. Print, and there are no arguments because I have declared it without arguments and without return. So what do I do it? Print the elements of the That is what I'm going to do here. That's a comment entry. How do I do that? I have to use a loop here. For I is equal to 0, I less than or equal to rare, I plus plus. So what am I going to print here? I'm going to print C out Q of I backslash T for tab spaces. So print the elements of the queue. The elements of the queue are this. So I will say C out enter the elements of the queue. So I'm saying the elements of the queue, and then I'm printing the elements of the queue separated by a tab space, and this is the end of my print function. I is equal to 0, I should be less than or equal to rare, because rare would be pointing to the last element, current last element. It need not be the size minus 1th element. If there is only one element, it would be the 0th element location, the element at the location 0 only. So it would be pointing to the last element which was entered or pushed inside the queue, and then from 0th location to that you are going to print in all the elements of the queue separated by a tab space. So we finish the class here. Hopefully you have understood this. Now I am left with what? My main function. I need to write main, because without main I will not be able to execute my program. So CLR SCR clear screen. Then what I have to do? First, let me create an object for the class. So QObj is the object, Q is the name of the class to which I am creating an object. So whenever the object gets created, memory would be allocated for the class, and then the front and the rear pointers would be assigned the value -1. Okay, and now let me have int. Yes, why? Because I need to take in that and pass as an argument to the function. So you should either I can have the same name or a different name, data type and number should match. So let me name it as item only, so that there will be no confusion like which is the actual parameter, which is the formal parameter here. But the actual parameter is the one in the function call, and formal parameter is there in the function header. So let me say int item and char, let me have char ch is equal to y. This is declaration and initialization in one step, and then in function I can declare and initialize, but in a class I cannot do that, and this is the lowercase y. I'm going to do it. Fine. So let me start while ch is double equal to y. What will I do? See, first I need to take in the element, right? Then only I can pass it as an argument. So C out, enter the element to insert in the queue. So What is the variable I have declared? I have declared item here. You can see here I have declared int item. So whatever the user entered will be put in here. After that, once I do this, what should I be doing? I need to call the function. Which function should I call? I need to call the enqueue function because I need to insert it there, right? So how do I call a function? I call a function by object name dot the function name. What is the object? The object is qobj dot enqueue item. This is how it is the function call. This is the function call. I'm calling the function and I'm passing the argument, that is item. Where is the item taken? I have asked the user to enter an element to insert into the queue. I am taking it and then I'm calling the function enqueue and I'm passing that as an argument there. After that, what will I do? Let me also call the queue print function because I want to see, like every time an element is inserted, I want to see the latest queue update. So I will do that. Dot print. Okay. After that, see out and I'm asking the user, do you want to continue or do you want to add one more element? Because as a user, I may want to add one more element. So, do you want to add one more element? Okay. Yes or no. I'm asking the user, do you want to add one more element or not? See in ch. Yes or no is a single character. So ch is equal to 2 lower ch. Okay. Why am I doing that? 2 lower ch? Because as a user, even if I enter in uppercase, it means that I would want to continue, but to the system, it differentiates. C++ is a case sensitive language. It differentiates between the upper and the lower case. That is why I am converting it into one case. If I enter a lower case, it remains as it is. If I enter uppercase y, it would get converted into lower case and put back to ch. After that, let me also print one more thing. If ch is double equal to y, yes, I want to continue. I will say out and there's no need of and out. What will continue do? Continue will go to the function header. Else, what will I do? I will say out end of enqueue end of enqueue operations. And then I will close this. Then I need to close my while. My while is also closed here, and then get ch and I close my main here. Fine. So this is how I write my program. Hopefully I've made a note of this. what did I do? I first declared a class and then I wrote the code for all the functions declared inside the class. Then I created an object and any number, not only one, the user can enter any number as long as there is place in the queue. So that is why I had put it in a loop. And then I took the item which has to be inserted, called the enqueue operation, and passed the item which is taken from the user as an argument. And then I call the print because I want to see the elements of the queue every time an item is inserted or pushed into the queue or added to the queue. Then after that, I am asking the user, do you want to continue or add one more element? If the user says yes, continue, it will go back. If the user says no, what happens? End of enqueue operations, and then my while loop ends over here, get ch, and my main ends over here. Hopefully you have understood this. Please go through the notes what you have written of the program. Then I will show you the execution of it. We'll see the execution of the program. Okay, this is my program. Hash include IO stream and all include statements. Why am I using conIO here? I'm using conIO for clear screen and get ch functions, and then I have c type dot h header file define hash define size 5. So what is the value of size? I'm giving a value 5, and then class is a keyword, so it has to be written in lowercase. Then I have q. Q is a name of my class, and then opening the class like I have in the private section. Private is the access specifiers. What are the variables declared here? I have declared int, q of size, frar, front. I don't need item here, so I can take it out. Yes, because I would be passing it from the calling function as a argument. Rar and front and I. So these are the data members of the class Q declared in the private section of the Q. Then I have in the public section Q, and then I do have enqueue is a function which does not return any value, and I am going to pass an argument to it. So how many arguments I am passing? I am going to pass only one argument, and the data type of the argument would be integer. So this is called function declaration. So I'm closing it here, function declaration, because I would be defining it outside the class. So after that, void print is a function which does not return any value, and I'm not going to pass any arguments to it. Then I end my class. Our class has to be terminated with a semicolon. So if you forget to put this semicolon, there would be a lot of errors. So make sure you don't forget. Then I'm going to define all the three outside the class. Since Q does not have any return type, I'm not writing it here. And then Q is the class to which it belongs to. Scope resolution operator and Q is the function. What am I doing here? I am giving initial values to rear and front, which is equal to -1, because when the queue is empty, front and rear would be -1. After that, I am closing my function over there. I am defining the second function, which is enqueue. So what was the return type of the function? The return type of the function was void. Void means the function does not return anything. So if the function is not returning anything, you specify it as void, because Every function should have a return type, the name of the function, and an argument list. That is how my function should be. But then here, since NQ is not going to return any value, I am going to make it as void name of the class to which it belongs to. That is, I have declared NQ in the Q class. So name of the class to which or in which it is declared is Q, scope resolution operator, and then the name of the function along with the argument list if any. Here I need to give the formal parameter name. So what am I naming it? Item, and it is of type integer because I have in the function also I have declared that it would have one integer argument passed to it. Then my first step whenever I am inserting an element is to check whether there is any place in the queue or not. That is, I need to check for the queue full or the overflow condition. If rare is equal to size minus 1, then queue full overflow return. Else, if this is not true, then I have to check whether it is the first element in the queue or it is not the first element, but then I do have place in my queue. So if front is equal to minus 1, front would be minus 1 only for an empty queue. I will say front is equal to 0, rare is equal to 0. In the else part, I have suppose if it is not the first element, then I am just incrementing the rare. Okay, and then q of rare is equal to item. So I am inserting the item in the queue of rare position. I am closing the external else as well as my function. Then void queue print, that is the return type of the function is void, name of the class in which it is declared or it belongs to is queue, scope resolution operator, and I am calling the function print. So see out, enter the endl queue contents. It is not going to ask me to enter because I would have already entered it in enqueue function. Only thing is it is going to show me the contents of the queue whenever it is called. At that point, whatever are the contents of the queue, that contents would be displayed on the screen. So I am having a variable I is equal to 0. I is equal to 0 because the location of the first element is 0, and then what would be the last element? The last element would be equal to wherever rare is pointing to, that would be the last element of the queue. So I should be less than or equal to rare and I plus plus. So see out q of I. Don't print I because it will print you 0, 1, 2, 3, 4 only if you just print I. So you need to print the element in the location of I, and then backslash t is to give a tab spaces in between the elements. After that, clear screen, which will clear the output screen every time it is encountered. Then I have to create an object. Why do I need to create an object? Because if I don't create an object, then memory would not be allocated, as well as I cannot access the data or the member function inside the class without the help of an object. So I am creating, what is the general syntax of creating an object? The class name space the object name. So I created an object QOBJ. Then I also have a variable char h is equal to y. So I'm declaring and initializing a variable to y here. Int item is an integer variable because I need to take in this value. I need to pass it as an argument, right, to the enqueue function. So I need to take in this value while ch is equal to y. So while it is true, what am I going to do? I need to take in item, then call the function and pass it as an argument. So enter an element. I'm going to ask the user to enter an element C in item because whatever the user entered would go to item. Then I'm calling the function enqueue and I'm passing item as an argument. This is called the actual parameter. That is the parameter in the function. Calling function is like in the function call, during the function call, the argument which you pass is called the actual parameter, and in the function header it is called the formal parameter. I'm going to pass item there. I've taken the value here which has to be pushed into the queue, and then I said I want to see what are the elements at that present location, so I will call the function print. After that, do you want to continue? Depending on the user's choice, I will continue or not. And we'll go for the execution of it now. So, shall we run it? Yeah. Run. Enter the element. For example, if I enter 45, it shows me the queue contents also as 45. Do you want to continue? Yes. Enter an element. Let me say I want to enter 78. So here you can see 78 is not placed in front of 45. It is placed behind. So the insertion is happening at the rear, not in the front. So let me say yes, I want to continue. Let me insert 66. Yes. 45, 78, 66. These are the contents of my queue. Yes. Enter an element 4. Yeah. 45, 78. Like here, every element which is inserted into the queue is inserted at the rear of the queue. It is not placed in the front of the queue. Do you want to continue? Yes, I do want to continue. And then let me say I want to enter 6. So, do you want to continue? How many elements are there? 1, 2, 3, 4, 5. 5 elements are there. What was the size I declared? It was also 5. Again, I'll say I want to continue. Enter the element 6. But then it is showing me queue full overflow. Why? Because maximum elements I can have is 5. If I try to input or insert one more element, one thing is I need to delete an element, then yes, even if I delete an element also, in this queue I cannot insert because the elements do not shift to the next location. So I cannot insert an element in the queue if I delete one element. I need to delete all the elements in the queue because rear would be pointing to the n minus 1th element. It will not get shifted. It will not get shifted to the front. Getting it? Because if I delete 45, front would point to 78, but rear would be pointing to n minus 1th location only because 78 does not move to the front. So even if I delete one element, it is not like stack. Even if I delete one element here also, I will not be able to insert an element in the queue unless and until I delete all the elements of the queue and insert it. Getting it? No. End of queue operations. So, suppose many of you were confused with the front and the rear. So, let me print the value of the front and the rear. How do I do that? Let me see. Let me run this. Run. Enter an element 56. So what is the value of front and rear, I told you if there is only one element, you will be resetting the value. I will be resetting the value of front and rear to 0. So Q contents is 56 and the value of front is 0, rear is 0. So do you want to continue? I will say yes and I will enter an element. So front remains 0 because I have not deleted the element in that location. Once I delete, then front would be +1, which will point to the first element because it is already the 0th element is deleted, so it will point to the first element. The Q contents are 56 and 56 because both the times I entered 56. Do you want to continue? I will say yes. Enter the element 54. Q contents are this: rear is 2, front is 0. You can see the rear keeps on moving, but front remains in 0 only. So what should be the value of rear for Q overflow? It should be 4. That is n is size is 5. So size minus 1 is 4. Let me see. If I enter, what is the value of rear? Rear is 3. And then there are four elements in the cube. So I will say I want to enter. What is the value of rear? 4. And front remains 0. Do you want to continue? Yes. Q overflow. So end of Q operations. Hopefully you have understood this. Let us close this. Yes. File, exit or quit. So we saw the execution of the insertion operation. So as I said that, see, when I delete an element also, for example, I have rear is pointing to the last element, that is the n minus 1th element, and I delete some elements in the front. But these elements, like if I delete an element at the 0th location, front moves to the location 1, but the element in the location 1 will not be shifted to the 0th location. So, suppose I delete all the elements and front and rear are pointing to the n minus 1 element. That is, only one element is there. So, front also is pointing to that and rear also is pointing to that, and the entire other four elements before that are not there. But still I will not be able to insert an element because it will show me Q full. The elements when you delete will not get shifted to the blank spaces. Front itself moves from one location higher. To overcome that, because you will be wasting, it will always show you even with one element. Suppose you have it in the n minus 1th location, you will not be able to insert. To overcome that, you have a concept called circular queues, wherein the first node is connected to the last node. When we do deletion, yes, we will do that. I'll tell you exactly how a circular queue works. So once you delete an element, it allows you to insert in a circular queue. But in a normal queue, what we did, until and unless I delete all the elements in my queue, that is, once you rear reaches n minus 1th location, I want to insert an element, then I need to delete all the elements, make it to an empty queue and start inserting, because the rear position or the element does not shift, the pointer itself shifts here. Getting it? Yes. Once you delete an element, if q place is not there, if q is full, you delete one element, you can insert, but that is in the case of circular queues. Hopefully you have understood today's class. Where please write down the homework question. Write a program to perform NQ operation. So please make a note of this, and we'll discuss circular queues. What is the drawback of this singly queue, and then what is a circular queue? We'll discuss that in detail when I do deletion. But the thing is, yeah, if there is a queue full, you delete one, you can insert in the case of a circular queue. Whereas in this queue, until and unless once the queue becomes full, and then you delete all the elements, but only one element is left in the n minus 1th location also, you will not be able to insert, because the elements do not get shifted to the vacant locations. You need to delete all the elements and then you can insert into that. To overcome that problem, you have the concept of circular queues, wherein the first node, that is the last node, is connected to the first node. We'll do that. I'll explain what is the exit condition, because again there also you will have to check for the queue full condition, but you will not be writing a program on that. But I'll tell you like what exactly is that and how is it beneficial to a normal queue. Hopefully you have understood today's class. Take care, stay safe. See you tomorrow. Bye bye.